Good morning, dear students. Welcome to this session on Essay 2, Unit 3 lectures. Uh, Now we are in topic called Three-hinged stiffening girders for suspension bridges. Okay, so we have completed the part of cable analysis till this session, and now we will take up the suspension bridge girders as no, introduced to you in the initial lecture, that there are two types of stiffening girders based on the number of hinges available. So mostly the stiffening girders are of either two hinged or three hinged stiffening girder. So let us take first three hinged stiffening girder. So, what could be the girder? If you just let us answer what is meant by a girder. So, it is an element placed between the two piers which carry the load from the pathway or carriageway. Okay. So, vehicular load, movement of vehicles cause the moving loads as well as the dead loads from the pathway or carriageway. So carriageway has to rest on the girders. In turn, girders will try to transfer the load to the piers. Okay, so this is the mechanism that we will see very regular in case of suspension bridges. Okay, so three-hinged stiffening girder. Uh, I'll just show you the typical girder of. Okay, so this is how no, the two ends of the carriageway. So this is the carriageway that the vehicular movement is allowed on this. So the load from the vehicular movement. This is the carriageway. The load will be transferred to this girder. So girders are of just like a beam, but of different cross sections, maybe rectangle or mostly the girders are of I sections. Okay, so we will have I sections as the girders as I sections because the loads are heavy, and as we go for heavy spans. So load the bending moment on the girder will be very high. The just regular cross sections will not prove to be economical and safe. So that's why we will move to the girders shaped as mostly I section in the cross section, right? I shaped cross sections. So when you just flyovers, if you flyovers are very common. If you go around the underneath the flyover, you can clearly visualize the cross section of the girder, right? So that is how the stiffening girders are provided with the cross sections which are of mostly I sections. Okay, so as the load is heavy, I mean bending moment is heavy, it has to be it needs to be provided more depth. D should be increased enormously because M is more, bending moment is more, and it should be rigid no? Because the cable that you are providing, because they are all cable stayed bridges, so the cable to be to maintain the shape of the cable, This is another requirement, that the girder has to be very rigid. Okay, right. If the cable is parabolic, then you can assume the suspenders carry a UDL nature of load, uniformly distributed nature. Okay, this can be facilitated by providing a hinge at the center, as shown in figure. Let us see a typical three-hinged girder. So, if there is a hinge at the center and another hinge at the end, mostly another hinge at the end. Okay, so right, the cable shall run like this. So cable will have hinge support. A typical cable will have hinge support. This cable is connected to the girder in the form of suspenders. All these vertical wires are known as suspenders. So this is a main cable. So main cable that we call main cable. Main cable is connected to the girder. This is a girder. Okay. So main cable is connected to the girder by suspenders. So the load from girder is transferred to the suspenders, and suspenders in turn will transfer the load to the cable, and cable to the supporting tower. This the hinge support is nothing but it is tied to the tower. Okay, and as well the girder also rests on the partially rest on the supporting tower. Okay, so this is how the typical cable stayed bridge will be. Right, if you provide the hinge at the center, so we are making the assumption of uniformly distributed load. So hence the problem becomes statically determinate. Okay, otherwise it will be indeterminate. So we have seen in the case of arches where the three-hinged arch is determinate, whereas two-hinged arch is indeterminate. The same similar case of analysis here. So you will know the determinacy and indeterminacy of the stiffening girders when we actually work out a problem, right? Right. It is indeterminate. If it is indeterminate, then the force in the cable is different in every the force is different in every cable, right? So in the sense, suspenders also will try take different loads. So then you need simplification, because there are infinity number of suspenders provided, heavy in number. So you can't just analyze each and every suspender. Okay. So there needs to be a simplification for this. We will come to know when we talk about a two-hinged suspender, two-hinged stiffening girder. What is the simplification that we are going to make? So for solving three-hinged stiffening girder, you don't need any simplification. Just like the three-hinged arch, you can straight away take the problem because it is determinate. You can easily proceed for the analysis. Okay. So what we are assuming here is the cable profile is parabolic, so that you can use the assumption that the load is uniformly distributed. Okay, so that is that we are going to make. Right, this slide now will explain you how you solve a three-hinged stiffening girder problem. Okay, so in this slide I have tried to explain you how the stiffening girder is provided, what is its location, what is the purpose of it, and what is actually a stiffening girder. and how the load should be, and what should be the cable profile, right? Whether it is determinate or indeterminate. If it is indeterminate, what should be done? So this is what the slide will explain. Okay. So stiffening girder is like a heavy beam. Okay. So in simple way, if I want to tell you, it is a heavy beam, like very deep in nature and rigid. Okay. So why it is to be rigid? Because to sustain the cable profile, it needs to be rigid. Okay, right? So if it is not rigid, if it is flexible, right? So you know that the load can change the shape of the cable. That means cable profile depends on the load. So that's why, so when a vehicular load moving from one end to the other end, cable profile is going to be disturbed due to the load placement. So if it should not happen, that the you have to tie this cable to a rigid member. That's why we need the stiffening girder. That is one of its purposes, right? Okay, let's go to the procedure. How we are able to solve the three-hinged stiffening girder problem. Right, first isolate the cable. So draw free body diagram of the cable. So FBD of cable shall be prepared. FBD of cable, right? So what will be the unknowns in the cables, cable free body diagram? See, only one unknown, that is uniformly distributed load. Okay, because loads are applied not on the cable, on the girder. Okay, because loads are transferred from the carriageway to the girder. Okay, girder transfers the load to the cable. So load acting on the cable, you are not able to see the load. Okay, that's why it is unknown value. You have to estimate it. Okay, so once we know Q naught, then you can solve the rest of the problem regarding cables. Okay, cable unknown value. Right, so load on the cable is unknown value. Right, if you take the free body diagram of the stiffening girder, then you analyze it. Okay, right? How do you proceed for the stiffening girder free body diagram? So once you draw free body diagram of the cable, so you will know that the Q naught is unknown. Then you take free body diagram of girder. Okay, now you will have girder with the loads, applied loads, and the support reactions, and the load value Q naught also presented in the girder, right? So you take moments about the ends, you can find the relationship between vertical reaction and Q naught. Okay, so one of the ends you take. Okay, so formulate the equation where you will have unknowns Q naught, either VA or VB, whatever it is, vertical reaction at A or B. Okay, these are the unknowns that you have. Right. Now take the equation available in the girder at the middle, okay, where third hinge is provided. This is important, right? So moment at the third hinge should be made equal to 0. This is the additional equation that is required. MC is equal to 0, right? To formulate the equation again in terms of Q naught and VA, right? So from free body diagram of the girder, we are going to formulate an equation, equilibrium equation, Q naught in terms of Q naught and VA. Again, we use the condition of internal hinge MC is equal to 0 and formulate one more equation in terms of Q naught and VA again. So now there are two equations and two unknowns. So we solve for VA and Q naught. Okay. So once you solve Q naught and VA, you can solve for VB finally. So once you solve Q naught and anything related to cable unknowns can be solved, maybe cable support reactions or cable tension or internal forces in the cable, anything can be analyzed. Okay, so this is how a typical procedure of solving for the cable with three-hinged stiffening girder. Okay, right. So we will take up a problem in the next session, and we will see how we solve this three-hinged stiffening girders uh, example to solve. Right. Thank you.